You still preparing for that AP exam? Welcome back to AP Live. I have more tips for APCS principles. Today, we're going to be talking about binary numbers. I got some binary numbers back here, got my charts to help me practice with them, and we're going to take a look and do some problems with binary numbers today. One of my favorite topics. I am Mrs. Julia Lano from Hamilton Southeastern High School in Fishers, Indiana, and this is AP Daily Live for AP Computer Science Principles. So, what will we learn in today's session? So, quick overview. In this video, we will review the topics of binary numbers, data compression, extracting information from data, and using programs with data. So, those are the quick overview. So, what are the exact topics we're going to cover? Binary numbers. So here's a little bit more about binary numbers. We're going to be able to explain how data is represented using bits, explain the consequences of using bits to represent data. And for binary numbers, we'll have to do some calculating of binary equivalent, so base 2 to positive integer base 10 and vice versa. And we will also compare and order binary numbers. So my little chart may be helpful. Obviously, you can't take that into the exam, but you can write down those numbers as on your test. So as soon as you get it, not a problem. But yeah, can't take any helpful items like that to the exam. All right, some other topics covered: data compression. So we'll need to compare data compression algorithms to determine which one is the best in a certain situation or particular context. We will also talk about extracting information from data. So describe what information can be extracted, describe from the data and the metadata, and then identify challenges associated with processing data. And the final topic is using programs with data. So again, extracting information from data using a program or a code, and explain how programs can be used to gain insight into the knowledge from the data. The skills we're going to use today are evaluate solution options, implement and apply an algorithm, explain how abstraction manages complexity. That's actually related to our Create PT tip of the day. And then explain how knowledge can be generated from data, and describe the impact of gathering data. Really important one there. Lots of data gathered in today's world, almost being collected all the time with that phone you carry around in your pocket. All right, so here's the agenda. We're going to review some important terms and topics. We're going to take a look at some of that essential knowledge from, the year. We're going to try some example problems. We'll do some more multiple choice questions on your own or practice. You can pause to do those. And then we'll have that Create PT tip of the day. So hopefully you're close to finishing that, but we'll still give you a few tips here to make sure you're on the right track. So first off, some review of some essential knowledge and key terms here, little vocabulary, but that's really important for a lot of these lessons that we're looking at here. So first, what is bit? We just talked about a second ago. A bit is shorthand for binary digit. A bit is either 0 or 1. So yeah, my chart back here, I have it so I can flip up and make them ones. So there, and I have 8 bits on my chart, which is a byte. So there, that's what our second one is, right? 8 bits. And so this is just a helpful way. We might use it later, but again, and I'll show it on the slides actually. It's kind of better just to write it down on your test. So abstraction is the process of reducing complexity by focusing on the main idea, by hiding details of irrelevant to the question at hand and bringing together related and useful details. Abstraction reduces complexity and allows one to focus on the idea. So, right, reduces complexity, kind of, thinking a little higher up and not worried about the lower details. That's the idea of abstraction. So we're going to talk about that in today's lesson as well, and some of the questions we see. Here are a few other terms. Again, we're going to talk about these, and it's important to understand the difference between these terms. So data compression can reduce the size or the number of bits it takes to transmit or store items. So we can compress it so it doesn't take as long to transmit. And there are 2 forms of compression here: lossless and lossy. So lossless compression can usually reduce the number of bits stored while guaranteeing complete reconstruction of the original data. So you don't lose anything. It's lossless. And then lossy data compression algorithms can significantly reduce the number of bits stored or transmitted, but only allow reconstruction of an approximation of the original data. So you can shrink it more, but then you may not get the full thing back. So important to think about, and we'll talk about the pros and cons of those and see some questions about that. Here's some more final bits of important essential information. So here's term information, just to make sure we know that definition is the collection of facts and patterns extracted from data. We saw the word metadata earlier, so making sure we know what that is. Metadata are data about data. Gets a little funky there, but data about data. So for example, the piece of data may be an image, while the metadata may include the date of creation or the file size of the image. So if you go into your phone and you are looking at your photos, because I'm sure you have some on there, you can click on the photo usually and it'll give you the metadata. So the data about the picture. So you probably have the date it was taken, the size, all those details are stored as well. So data about the data. Cleaning data is the process that makes the data uniform without changing their meaning. So replacing all equivalent abbreviations, spellings, and capitalizations with the same word. So if you've ever given anyone a survey, cleaning data is important. Maybe you didn't give them options for their answers and they were able to just type their answers. So then if you wanted to analyze the data and look at it and somebody typed in like an abbreviation for a state and then somebody else typed the full name, you wouldn't be able to compare those. So that's what cleaning is. You would have to make them all the same. So that's an important process if you're trying to analyze data. As I said, we're going to talk about binary numbers today. It may have been a while since you covered binary numbers in your class. So if that's the case, you may want to review the daily video 3 for this topic. So the topic is 2.1, binary numbers, and there you see a quick little image of daily video 3. Daily videos are available on AP Classroom, and you have access to all of them. Your teacher may have assigned some videos to you, but you have access to all the AP daily videos. They are short 6 to 8 minute videos covering each topic. And some topics, there can be up to 3 videos. Binary numbers, pretty important. This video is excellent. You should check that one out, and it will help you review if you need further review with binary numbers. Got a little just for fun there. So if you know your binary numbers, little review there. There are only 10. Really, you need to say it 10, not 10. There are only 10 kinds of people in the world, those who understand binary and those who don't. If you get it, great. If not, maybe look it up. But 10 is, it's not 10. It's actually 10 in binary, which is 2. So, there are only 2 kinds of people in the world, those who understand binary and those who don't. Kind of a little joke. If you get it, great. If not, it's okay. But just thought I'd throw out some fun because binary numbers can sometimes be a little boring, a little scary. So no worries. I'm sure you will handle them well on the exam. All right, we are ready for some examples. So we'll see some example questions before we really do some practice with some others. Here is our first example question. A digital photo file contains data representing the level of red, green, and blue for each pixel in the photo. The file also contains metadata that describes the date and geographic location where the photo was taken. For which of the following goals would analyzing the metadata be more appropriate than analyzing the data? So again, we saw this in our topics and skills covered earlier. So we're talking about how we analyze data and metadata. So the metadata has the date and geographic location. So would that help me to determine the likelihood that the photo is a picture of the sky? Again, we're talking about analyzing the metadata. When would the metadata be more appropriate? So the metadata is date and geographic location. I don't think that's going to help me determine if the photo is a picture of the sky. Determine the likelihood that the photo was taken at a particular public event, possibly. Determine the number of people that appear in the photo. Don't think the metadata is going to help me with that. And determining the usability of the photo for projection onto a particular color background. Well, that has to do with colors, which are pixels, the level of red, green, and blue. So that is right. That's what it that's the photo, but the metadata, again, the date and geographic location. If we knew the date and where the photo was taken, we could see if there was a public event happening at the same time. So that is our answer B. So, right, the metadata can help us find where the picture was taken or if there was a public event going on there. Next one, here is our second practice or example question. Each student that enrolls at a school is assigned a unique ID number, which is stored as a binary number. The ID numbers increase sequentially by 1 with each newly enrolled student. If the ID number assigned to the last student who enrolled was binary number 10010011, what binary number would be assigned to the next student who enrolls? So again, if you needed to go back and review binary numbers, I suggest you watch that AP Live video. I'm not going to do a ton of review here. I'm going to give some tips. I'm going to talk about how I would solve this problem. So if you need to review binary numbers fully, you should go back and watch the AP Daily video. So remember that binary numbers kind of roll over just like our regular numbers. The tricky part is there's only two binary numbers, 0 and 1. But in regular numbers, we count to 9. When we get to 9, we ran out of numbers. So then we have to add a digit to our left. And then the 9, where the 9 one is 0, and we put the 1 to the left, and we make 10, right? And we go from 9 to 10. Or if we go from 99 to 100, we ran out of digits. So 99 kind of rolls over to the 0, and we put a 1 to the left. Binary is the same way. So in this case, when we, and you can also think about it with our, with the powers of 2 or your the actual numbers here of 128, 64, 32, what each one represents. So each binary digit represents a number. If it's 1, we include that number. If it's not, we don't include it. So remember that, so binary 1 is right here. The 1 is 1. Then to get 2, we set the 2 spot to 1. Then to get 3, we set these two both to 1, which makes 3, 1 plus 2. So in our problem here, I'm not even really worried about the left because I know this is 3. And so this other number is, a higher number, but we really need to look for what would be next over here. So if this was 1, this is 2, this is 3, what do you think is going to be 4? And you should be able to find the answer there. And again, it's just a little practice with binary numbers. So here, when I put the 1 over here, I ran out of spots. So I had to go to the next spot, make it 1, and these roll over back to 0. So that gives me 4. So again, I'm not even really worried about the first 4 bits because that's like having a bigger number. So when I count in regular numbers, when I count from 101 to 102 to 103 to 104, that 1 on the left doesn't change, does it? The same is true in binary. So all I was looking for was kind of the right. I know this is 3, and after 3 comes 4. And so my answer here, the left side's still going to be the same. And so my answer is A. So the left 4 bits didn't change, just that right 4 bits went on to the next number. So hopefully that little layout, and again, you can write all over your test. So the test is on paper, the test booklet you can write on, and you just bubble your answers. So feel free to write out those powers of 2, help you write out those binary numbers and understand those. Because you won't be able to take your chart in, but again, you can use that to help you, you can practice with that, which helps you be better prepared for the exam too. So if you make a chart like that, and again, I use it to flip them up here. So, right, I could say, oh, that's 1, and then here's 2, and then 3 and 4, and you can kind of use it to help you visualize the numbers. So if you have something like that, that's great practice to help you do it correctly when you're practicing. All right, talking about practice, here we are. We're ready to practice. We have 10 practice multiple choice questions to help prepare you today to do with binary numbers as well as those other data questions about data compression. So let's get started. Our first practice question of the day. Biologists often attach tracking collars to wild animals. For each animal, the following geolocation data is collected at frequent intervals: the time, the date, and the location of the animal. So let's collected often. Which of the following questions about a particular animal could not be answered using only the data collected from the tracking collars? Little wordy here. So if you need to underline when you're taking the test, look for the key terms here. And one of those is already all caps, not.
Which of the following questions about a particular animal could not be answered from this data? So it's the time, the date, and where the animal is. So it's happening a bunch of times. So we have a bunch of entries of, like say it's exam day, May 9th at whatever time the animal was here, right? So May 9th, May 10th, someplace else. So that's what our data is. So what can we determine from that data? Or which of the following could not be answered, right? Got to remember that not. So which of the ones could not be answered? Approximately how many miles did the animal travel in 1 week? Does the animal travel in groups with other tracked animals? Do the movement patterns of the animal vary according to the weather? In what geographic location does the animal typically travel? All right, so these are our questions that we are trying to answer. So which one could we not answer with that data? Right, talking about travel in a week, so we're doing date and time, other tracked animals, so if they all have tracking things, we should be able to compare the locations, and where would they go? Those all seem accurate. But the one about the weather, don't think that one quite works. We don't have anything to do with the weather. Now, we could go try to find out the weather, but it's not really being recorded. So, right, it isn't really there right now. So that is our answer, answer C. The movement patterns according to the weather, we aren't tracking or recording that. So if we'd want to know that, we should record the weather along with our data there. So that's your answer for number 1. At any time, if you want to pause, I got the little pause symbol there. You want to pause before I show the answer, you're welcome to do that so you can practice it a little more on your own. All right, question number 2. Which of the following is a true statement about data compression? Here are our options. Data compression is only useful for files being transmitted over the internet. Regardless of the compression technique used, once a data file is compressed, it cannot be restored to its original state. Sending a compressed version of a file ensures that the contents of the file cannot be intercepted by an unauthorized user. There are trade-offs involved in choosing a compression technique for storing and transmitting data. All right, so we have a few options here. Again, which of the following is a true statement about data compression? B stuck out to me as being no, that's not right, because we just covered that, right, there's 2 types of compression and we can fully restore using lossless. So I immediately in my mind was like, nope, B's not the answer. And then C really stuck out to me. I mean, even made a face that, right, we're not talking about security here.
That says unauthorized user. So that has to do with security. We're just talking about compression here. So again, I immediately thought, no, C is not true. And the first one, I kind of skipped over that, but only useful for files being transmitted over the internet. Seems kind of reasonable, but remember we talked about earlier when we went through the essential knowledge that compression helps with storing and transmitting. So that is not the case either. So that helps us to determine that the answer is D. There are trade-offs involved in choosing a compression technique for storing and transmitting data. Right. We may want to be lossless, we may want to be lossy, just depends on the situation whether we need the full file to be recreated. So there are trade-offs. Do we want it back? Do we want it to go faster? Right, better compression. Those are the trade-offs. All right, we're moving on to question 3. Here we got a nice chart of data. So we're going to do analyze some data here. The table below shows the time a computer system takes to complete a specified task on the customer data of different size companies. Based on the information in the table, which of the following tasks is likely to take the longest amount of time when scaled up for a very large company of approximately 100,000 customers? So right now, the tasks are backing up data, deleting entries from data, searching through the data, and sorting data. So we have these tasks, and you can see the time it takes for 100, 1,000, or 10,000 customers. But now we're thinking about scaling up to 100,000 customers, so a whole lot more. So again, we may want to go back to the question and make sure we know what we're looking for. which of these tasks, so there's 4 tasks, is likely to take the longest amount of time when scaled up. So if you look at the hours, you see that sorting for a small company starts at 0.01. That's my smallest number. All my other ones take quite a few hours. They start out taking hours. So 100 hours, 200 hours, 300 hours to delete entries. Just, a nice progression, linear progression, maybe, if you want to think of it that way. Backing up gets a little bigger, but it's just going by times 10, right? 2 to 20 to 200, just times 10 each time. And the searching, 250, 300, 350, again, going up by 50 each time. So those all kind of have general jumps that we can determine, right? I can tell up by times 10 each time, or up by 100, or up by 50. That bottom row, sorting data, we start very small, 0.01. So 1/100th of an hour, very small amount of an hour, right? And then an hour, and then 100 hours. So from 1,000 to 10,000 customers, we went from 1 to 100. That was a big jump, right? Basically, we're jumping pretty big there. So if we went up to 100,000 customers, what do you think that jump would be? Because right there, we jumped from 0.01 to 1 to 100. That was really fast. So that's what you got to think about. Those things happen really fast. Those others were pretty steady, up by 50 or just by times 10. But that bottom one, if we went from 1 to 100, if we go up to 100,000, that's going to jump a lot. So sorting data is the one that's going to take the longest amount of time. Even though those others are at 200, 300, 350, this one's going to jump even more. You don't even have to worry about what that number is, but know that it's going to jump tremendously, and it's going to jump more than those, because we can estimate the others already, but that one is going to go up way high. So sorting data is the one that's going to take the longest. All right, question number 4. Got a little wordy here again. Again, remember on the test, you can use, underline, circle the question, just like that last one. I had to look, which one am I, what's the question asking again? Go back, reread, underline. A video streaming website uses 32-bit integers to count the number of times each video has been played. In anticipation of some videos being played more times than can be represented with 32 bits, the website is planning to change to 64-bit integers for the counter. Which of the following best describes the result of using 64-bit integers instead of 32-bit integers? Maybe a little old, but yeah, there was this video, Gangnam Style, that broke the internet. Right, well, it did this. They ran out of room. There were so many views that the counter broke. So that's what we're asking here. So, but what is our advantage? How many more values can be represented? So, let's take a look here at and think about some numbers here. So here on the right, I'm going to write out some bits and think about our bits here, right? So remember, we're talking 32-bit numbers, and then we're going to move to 64-bit numbers. So let's think a little smaller first. So if we think smaller, we should be able to apply it to that situation, because we're looking at times here. Is it 2 times as much? Is it 32 times as much? Is it 2 to the 32 times as much? Which one is it that we got, or 32 to the 2? So if I have 2 bits, remember that 2 bits can represent 2 to the first, because 2 bits can go, I can do 0, 1, 2, 3. So I can represent 4 numbers, which is 2 to the second, or 4, right? With 2 bits, I can do 0, I can do 1, I can do 2, and I can do 3, right? Right there, I have 3. The 1 and the 2 makes 3. So then if I go to 4 bits, now I can represent 2 to the 4th, right? I can represent 2 to the 4th, because I can go from 0 to 15, which is 16 items, which is 2 to the 4th. So thinking smaller and thinking about how that works. So when we went from 2 to the second to 2 to the 4th, we went, that was 2 to the second more times, right? 2 to the second times 2 to the second gives me 2 to the 4th. Little math there, but we're just trying to review and make sure we know what happens here. We're talking times, and you should also notice that there's 2 bits. We can represent a number that's 2 to the second because there's 2 bits. When there's 4 bits, I can make a number that's 2 to the 4th because there's 4 bits. So 32 bits would give me 2 to the 32nd. And 64 bits would give me 2 to the 64th. So again, you're just looking at the difference in the exponents. So 2 to the 32nd, to get to 2 to the 64th, I need to take it times 2 to the 32nd again. A little roundabout there, but think smaller, because that problem seems a little scary, I know. But right, 32 bits we know can represent 2 to the 32nd. 64 bits can represent 2 to the 64th. So to get from 2 to the 32nd to 2 to the 64th, we got to take it times 2 to the 32nd again. So if you need a little more math review, talk to your math teacher there about exponents. But again, note that, right, everything with binary is based on powers of 2, and that can kind of help you there as well. All right, practice question number 5. A certain social media website allows users to post messages and to comment on other messages that have been posted. When a user posts a message, the message itself is considered data. In addition to the data, the site stores the following metadata: the time the message was posted, the name of the user who posted the message, the names of any users who comment on the message, and the times the comments were made. For which of the following goals would it be more useful to analyze the data instead of the metadata? Here, I keep saying them different too. Data, metadata, data, metadata, doesn't matter. So which of the goals would be more useful? To determine the users, again, I may have to reread the question again. Which of the goals would be more useful to analyze the data? Remember, the data is when a user posts the message itself is considered data. So underline those parts, circle whatever you need to do on the test. So the data is the message itself. All right, so which of these would be helpful? To determine the users who post messages most frequently, to determine the time of day that the site is most active, to determine the topics that many users are posting about, or to determine which posts from a particular user have received the greatest number of comments. Okay, review the question again. So the message itself is considered the data. So what is your message? So if my message was, oh, it's hot outside, then that's the data, that text or that what's in that message. So that really doesn't tell me who posts most frequently, because it's just the message is the data. Doesn't tell me the time of day. It doesn't say anything about comments. So while they talk about this other stuff being metadata, we're focused on the data here. So you can mark out, there's extra stuff we don't need here. So what would that message tell me? It would help me to determine the topics that many users are posting about. A lot of people are talking about how hot it is. There we go. We can determine that they're most are posting about. So C is your answer for question 5. All right, question number 6. A certain programming language uses 4-bit binary sequences to represent non-negative integers. For example, the binary sequence 0101 represents the corresponding decimal value of 5. Hopefully you know that. Using this programming language, a programmer attempts to add the decimal values 14 and 15 and assign the sum to the variable total. Which of the following best describes the result of this operation? All right, so in this case, we want to think about that we only have 4 bits. We just talked about this on a couple slides ago. And again, write it on your test, write down what 4 bits represents. And remember, you write down your powers of 2 or the numbers that those powers represent. But if I have 4 bits, I can only represent 2 to the 4th. And remember, we start at 0. So 0 through 15 is all I can do with 4 bits. I can only do 16 values, 0 to 15. So if I can represent 14 and 15, right? 14 would be 0, 1, 1, 1. Oh, sorry, that's wrong. Sorry. It would be 1, 1, 1, 0. Right. 1, 1, 1, 0. That would be 14. And 15 is 1, 1, 1, 1. All of them. And so if I try to add them, and we can add them too, 14 plus 15 is 29. I know 4 bits can only hold 0 to 15. So if I try to add 14 plus 15, which I can put in 4 bits, 29 can't be represented with 4 bits. So whether we understand how we actually add zeros and ones, we know that the sum is 29. And so here we can take a look at the fact that the first one says the correct sum of 29 would be assigned. Nope, not going to happen if we only have 4 bits. An overflow error will occur because 4 bits is not large enough to represent either of the values 14 or 15. Nope, we can represent 14 and 15, 1110 and 1111. So answer C. An overflow error will occur because 4 bits is not large enough to represent 29, the sum of 14 and 15. I think that's what I was figuring out there, right? Or a round off error will occur because the decimal values 14 and 15 are represented as approximations due to the fixed number of bits used to represent numbers. No round off. I can represent, again, 14 and 15 are fine, but the answer 29 will cause the overflow. So here we are, C again. That is our answer for question 6. All right, moving on, question 7. More binary. I know you love it. I do for sure. So again, might want to review it if you struggle with it. There aren't a ton of questions, but it is, there are questions like these on the exam. Consider the 4-bit binary numbers 0011, 0110, and 1111. Which of the following decimal values is not equal to one of these binary numbers? So the best thing to do here is just to convert them. So here is my first number. So 0011 means that the last 2 digits are on. So that's 2 plus 1. So that is 3. And then my second binary number given is 0110. So that means the spots where 4 and 2 are ones. That means we add those together. 4 plus 2 gives me 6. So right now I got A, I got B. So now the last one is 1111. I just talked about it. Hopefully you remember 1111 means they're all ones. That means we add them all up. 8 plus 4 plus 2 plus 1, which is 15. So we know the answer is C again. Oh, I tried to switch these around and not have C so much. So there it is. Again, write this down on your test. You can write on there. Just remember how your binary numbers work and you'll have no problem with questions like these. All right. This one was definitely in the information earlier in our essential knowledge that you would need to know how to order numbers. And here we have some binary and some decimal. So here, consider the following numeric values. Binary number 1011, binary number 1101, decimal 5, and decimal 12. Which of the following lists the values in order from least to greatest? You can start to take a look, but again, the best thing to do is convert. So here's my conversion. So the first binary number is 8 plus 2 plus 1, obviously gives me 11. So then you write that down, mark it out on your test and say that's 11. And then my second binary number is 1101. So I'm going to take 8 plus 4 plus 1 there, which gives me 13. So now that I know and I've converted those to decimal, 11 and 13, it makes ordering them so easy. So obviously decimal 5 is first, and I can eliminate D. Then we go to 11. Remember, we had one of them that was 11, so that's our first binary number here. So after 5, I should have that binary number. So now I'm down to A or C. And then we knew that the next other binary number was 13. So then we should go to 12, and then our other binary number should be last. So our answer is A. So hopefully that makes sense. Again, I would just convert the binaries to decimal and then easily order them using those decimal values. 2 to go. Practice question 9. A large spreadsheet. I tried to cram some on there, but a large spreadsheet contains information about the schedule for a college radio station. A sample portion of the spreadsheet is shown below. A student wants to count the number of shows that meet both of the following criteria. Is a talk show, is on Saturday or Sunday. For a given row in the spreadsheet, suppose genre contains the genre as a string and day contains the day as a string. Which of the following expressions will evaluate to true if the show should be counted and evaluates to false otherwise? Okay, lots of words there, lots to keep track of. So let's go back to the first part. Says a student wants to count the number of shows that meet both the criteria. So we need it to be a talk show and on Saturday or Sunday. Oh, I just said a big word there. And, right. I need it to be a talk show and I need it to be on Saturday or Sunday. That's going to help us here. We're talking about code here and we're looking at data. So this was another one of our essential knowledge up there that we need to be able to analyze our data, use code to analyze data. So here we are. So we said we need the genre stores. So right, we have our genre variable. And again, they need to explain that genre and day are there, but they're all the same. You don't really need to worry about, right? We're looking for the differences in our answers. That's a key to helping you kind of move quicker or, get to your answer sooner. So we all see genre equals talk, genre equals talk, genre equals talk, genre equals talk. So, right. And then we have day, Saturday, day, Sunday, day, set. That's all the same. The key is the and or ors. And I just kind of said the answer because I said it needs to be a talk show and it needs to be on Saturday or Sunday. They even or is right there in the question. So if you need both, remember that needs to be an and. So we need an and then an or. And we also need to make sure that the or happens first. So ands come before ors. So you see here on answer B, we have some parentheses, extra parentheses there that say, oh, see if it's Saturday or Sunday, and then see if it's also a talk show, right? We have to kind of see if it's Saturday or Sunday together. So the parentheses really aren't important. It's all about this. Here it's and, here it's and or and or. So as we said, we need it to be B and then or. So again, look for the differences, but the key, and that should help you to determine what you kind of got to think about for the question. And that was just simply that I need the and then the or. All right, one more practice question to go. A database of information about shows at a concert venue contains the following information: name of artist performing at the show, date of the show, total dollar amount of all tickets sold. Which of the following additional pieces of information would be most useful in determining the artist with the greatest attendance during a particular month? So we're looking for the greatest attendance during a particular month. So we know the date of the show, we know the total dollar amount of all tickets sold. But if we want to know attendance, then average ticket price is probably not, average ticket price would, in this case, be helpful because we know the total dollar amount and we want to know attendance. So if we know how much the tickets are and we know how much money was spent in total, then we could try to determine attendance. The link of the show isn't going to help me much. The start time of the show isn't going to help me much for how many people are in attendance. And then total dollar amount of food and drink sold during the show. Well, more attendance would mean there would be more food and drink. That's not always the case. So because we already know total dollar amounts, we can take that ticket price, average ticket price, to estimate the number of attendance and see who has the greatest attendance during a particular month. So A is your answer there. Again, you want to eliminate answers there and look for the keywords in the question, which would be most useful in determining the greatest attendance. And so, and already looking at what you already had there, that was very important, that we knew the total dollar amount. So that is your answer for question 10. That concludes our multiple choice question practice. Now on to your Create PT tip of the day. Again, hopefully you're pretty close. That Create PT is due real soon. So here is a tip. Be sure your list manages complexity in your program code. It is very important, and oftentimes students write about how the program would be different. But the key here is be sure your list manages complexity in your program code. So a great way to explain that is explain how your code would be too complicated without the list. So explain how the code, not the program, not how the program wouldn't work, but how your code would be too complicated to write if you didn't have a list in your code. So think about how you would write it without it. Tricky because we don't really do that, but think about how you would write your code if there was no list to use, and that should help you to explain how it manages the complexity, because the code would just be way too complicated without your list likely. So you can see the link below here on the right for more PT instructions, rubric, and videos, and more help. Again, hopefully you're close to finishing that up and have had time to do that, because it's due real soon. And so that's why we're focusing on multiple choice during this AP Live videos. So what should you take away from today's session as we wrap this one up? Key takeaways, here are our topics. We talked about binary numbers, data compression, extracting information from data, and using programs with data. We saw multiple choice questions on all those topics there at the end. So hopefully that helps you see what you need to know about those topics to do well on the multiple choice. Want to review any topic further? Remember, you can check AP Classroom for all the AP Daily videos of any of the above topics. And don't forget to join Sandy Chaika tomorrow for a review of the internet. Great topic, and she'll do a great job with that tomorrow. And I will see you next week. Thank you so much for joining.